Arthur, Bruce, Charles, David, Frederick, how's it? A lot of people already. Jaco, how's it? Lots of familiar names in here. Johan, nice. What else we got here? I see Philip, I see Terrence, Theo, hi Theo. Hi Vian, Winston. Oh, some more and more. The list is long now to get through the whole list here. But amazing. Good to see 72 people already in. Let's give it another minute until everyone is in. Let me know. Just give me a quick hands up or a thumbs up if you can hear me, if you can see the screen. You see my little red laser pointer in here. Just that I know that everyone can hear me. Perfect. That looks good. Thank you. Thank you. Oh, I see Greg as well. Greg, how's it? Brian also here, joining with a little video quickly here, but perfect. Cool. Let's 76. I think that's pretty good for the first 2-3 minutes. I'm pretty sure there's a couple of more guys going to join. South African time is always 10 minutes late, fashionably. So I might just take a couple of minutes. Okay, cool. Let's start. I'm going to start the presentation. I'm going to start the webinar with a little start with our online shop and products which are available in our portal. So I'm just going to do that like 5 to 10 minutes max, and then I'm going to hand over to Kyle, and then he will do the main presentation today in regards to the Solar MD products. All right. First of all, I hope everyone is signed up with IBC, has got a portal login, and if not, let us know right into the chat. Give us a shout and speak to your sales manager that you get an online shop login so you can receive news and all information we send out, as well as you see specials online and all the products and can shop online. So which makes the access to IBC products much easier. Cool, let's go. So the start, the start is obviously I'm going to start with a quick presentation on the online shop, and then I hand over to Kyle, and then he is going to go through the product range of Solar MD. He's going to present the low voltage and high voltage batteries, the monitoring with the Solar MD logger and the control of it. And then we're going to go a bit more into detail into the commercial battery storage solutions, where we're obviously going to use the high voltage batteries. I'm pretty sure some of you have already used them. And we're also going to introduce the supported inverters. So what inverter brand can you use with it? Because I know everyone is always looking out for, okay, as soon as I'm over like a normal SMA, Sunny Island, or Victron Quattro system, what else can I use for hybrid inverters? So we give a little introduction into those and which are compatible. And then also for bigger commercial projects, we're going to speak a little bit about the monitoring and control of those, the EMS for such systems. All right, first of all, I want to say I think everyone read it, and I think also that drove the attendance up today. So everyone who's attending the webinar is going to get a voucher for 830 Rand. So this voucher is going to be once per company. So like if someone is in here with like 10 employees, you only get one. Sorry. So it will be only one voucher per company, and only for attendees only. So the voucher code will only be revealed at the last slide of the presentation today. So you have to stay with us, listen to what we have to say. So not just grab the voucher at the beginning and then run away. So that voucher will only be released at the last slide. So stay on, check out the presentation, and then at the end you'll get your Rand 830 Rand voucher. I think for like 1.5 hours, max 2 hours listening, it's not a bad thing to get, 830 Rand. Okay, cool, perfect. Another sneak peek already also onto next month's special, which is going to come out on Monday. At the moment, we're driving quite a bit into the commercial range, and so into the commercial projects, and therefore we're offering a free PV manager design for any grid-tied project over 100 kilowatt peak. So if you have a project over 100 kilowatt peak, you're welcome to send it in, speak to your sales manager, and then he will connect you to our technical team, and we can then do a free PV manager design for you. If you don't know what PV manager is, we have trainings on it. It's our own in-house software. I'm gonna give a little bit infos in a bit as well. And that's going to be our new special for next month. So come with your project to us and you'll get a free PV manager design to check it out, and maybe you like the software, and then you can also purchase it from us. All right, cool. Let's jump into the shop. So if anyone has any questions, by the way, please write them into the chat, and either myself or some of the colleagues are going to answer it for now. And also, like when Kyle is presenting, write it in there. I might take the question and I'll bring it up. I'll present the question, and then we can answer it and have the answers all together. Perfect. Let me pull up this one. Oops, can close this. Okay, there we go. Let's start with the portal. Okay, cool. As said earlier, if you don't have access to the portal, let us know, please, and get in touch with your sales manager and get a login to the IBC portal and online store. Okay, the first tile is the online store, which we're going to have a look in a bit. Second tile is a PV manager. We spoke about the PV manager. I said it earlier before. PV manager is our design tool, which you can purchase from us. The fee of the PV manager is 2,450 Rand per year. So that's our yearly fee. In Europe, for instance, this 2,450 Rand is a monthly fee for PV manager, and it's quite a successful tool. And we're integrating and pushing it much more in South Africa at the moment. And I think we have over 60 or 70 sign-ups for it, companies using PV manager. So, and they're very happy with it. We do trainings on it every month, every first Thursday of the month. So you can join it, have a look at it. It's a very cool tool for 3D planning of your projects, houses, do string layouts, mounting system layouts. Most of the systems or softwares you're using out there they don't do much with mounting systems. Like your helioscope doesn't really give you a bill of material. This system here gives you a bill of material with all what you need, down to the last screw, cabling and sizing and all of that. So it's very useful. And once you've finished your project, you can actually send it with one click into the IBC online store. You will see that in a bit as well. Cool. Let's go back here. Sales support tile. There's just a little bit of some information. There's questionnaires in there, which you can download and use, which can be quite helpful. Then also our IBC power calculator. I don't know if you have seen it. It's on our website. So this is a very quick calculator. So you can do a very quick online design for a client if you want to. Or what you also can do actually is you can actually also buy this from us. So you can buy this online calculator from us and integrate it onto your website. So to actually, if people come onto your website, they can type in their address and then they can do their own little design. And if they press OK, the information gets sent to you directly, and you'll already see the address and what they designed on their roof. So it's quite helpful actually to attract leads into your company. So we can actually integrate this into your website. This is also something we offer from IBC headquarter in Germany. Then next tile, downloads. Downloads is a historic, so you can find anything what has ever been within the IBC portfolio, any data sheets in different languages, certifications, and all of that. So very helpful. Competence Center here on the right. Competence Center is our webinars, so you can easily see any upcoming webinars and trainings and all of that. Price list information. This is an Excel sheet price list. So if you want to take it with or you want to integrate it into your calculation somehow, you can download the Excel price list under this tile. Other than that, you can obviously use the online shop with all the pricing. Then technical services. Technical services. Slides are moving. Is everyone still on track here with me? Is it lagging or is it working fine? Just let me know quickly. Not that I'm at a very different slide than everyone else. Okay, cool. I got some thumbs up. Okay. Then Dylan, maybe it's on your side if it's not moving. Maybe lock out and lock in again. Okay. So our technical services, which we've been offering for quite a while now and has been very successful. So we offer commissioning and fault finding. So if you have issues on site or it's the first time you're installing something, now we're having the SolMD high voltage training today. So if you're not sure about your first installation and you need support on site, let us know, and we make sure that we have a technician going with you on site and supporting you with the commissioning and all of that. So we can offer that extra services. Same like with PV Manager designs. Now we're having a special get free PV Manager designs from next month. But other than that, we offer PV Manager designs as well, single line diagrams, whatever you need for, let's say, City of Cape Town registration or with any municipality registration, and you need a single line diagram for that, we can do that single line diagram for you as well. And that's all kind of like information or services which we offer on our from IBC directly. So there's a little download, and then you can check and see what else services we offer. Cool. Then order management. We just implemented that a couple of months ago. Not sure if everyone has seen it already. Order management. If you go onto order management, you can see all your past orders. Let's go to the top one here. We start with the first one, confirmed orders. So you can see your open invoices here. Okay, what is open at the moment? Then you can also see your credit limit here on my side in my system here. It said like 1 million Rand credit limit. At the moment, I have nothing open or I haven't used the credit limit, so I'm still can purchase for 1 million Rand. My payment terms is 30 days after invoice, and my shipment term is X works. So you can see all of that in your portal. And my screen is a bit flickering here. I hope not on your side. Okay, it's back. Then below here, I put in some test orders. So you can see here any open order. So this is all confirmed orders at the moment, and they haven't been shipped or anything like that. This is just open orders, which you then also can, if you click on it, which you then also can download. Yeah, that's coming up here. So and then you can download those. So it's not always necessary that you actually get the information from us sent, but you would also get this in the IBC portal. It's a bit slow right now, I think, with all the traffic here right now. Okay, perfect. You see, and then here you find the performer invoice uploaded for a SolarMD high voltage battery. Also, what will be is open invoices. So you will see any invoice which is open. I have none open at the moment because it's my test account. Recent shipments. So you would also see all delivery notes, as well as invoices overview. Invoices overview will be your tax invoices with all kind of like information towards that. So this will be very helpful for you to track invoices and anything within IBC, so you don't have to actually ask anyone at IBC for an invoice or anything like that. You will be able to find that in the online portal. Perfect. Then my IBC, if you want to add a new colleague, go to my IBC user administration, and then you can add new users to your system, and your colleagues can have access with their own email addresses to the IBC portal. Industry guidelines. Industry guidelines is SSEG information. We actually have got your sub-via information and PV green card, where to get it, where to do it. So you can get all of that, and also contacts to any of the municipalities. That's links to the municipalities where actually SSEG is in place. You can see here where it's red where SSEG is in place, and you can apply. So you can actually use these to get to the websites of the different municipalities in South Africa. So very useful links. Okay, cool. Let's jump to the online shop. I see there was a question. PV Manager question. Yeah, I would ask PV Manager Winston. Let's keep PV Manager questions specifically for a training there, or let's I'll answer it later. I'll send you an email. It's yeah, not for this training to go too deep into the PV Manager. Okay, cool. So let's go at the front here, the start. So there's our online shop. Here now, obviously in the slider, you see the training. You see also the current special at the moment in the slider, which is still a couple of days valid. So if you have a system bigger than 30 kilowatt and you're using a GoodWe inverter, IBC mounting, and from us, and you buy from us panels, you get a 5% extra discount on the full system. So, which is quite a lot. So yeah, if you have something going and you want to use a GoodWe inverter in this system bigger than 30 kilowatt, do it now and receive an extra 5% discount. Oops, sorry, now I clicked on it. It's a bit lagging here on the speed now, I think. Okay, let's move on. So in the online shop, it locked me out now. Sorry, for some reason. Okay, now I'm back. Yeah, now it's coming back. Sorry. Okay, so if we see in the overview here, the front side, you can see current highlights, products which are highlighted, and also all our categories at the bottom, as well as above here, you can see the different categories. So let's have a quick look at PV modules. PV modules was a big problem for a while, but that has been resolved. So PV module stock looks much better now. So also what changed now is new is our availability graph, which is actually pretty nice now. So in the first view, you see already what is available when, and you see, okay, this is per week. So you can see 3, 4, 5, in 6 weeks time, we're getting the new 425 module in here as well in 5 weeks time. So you can see in the overview right away what is available and when. So very cool actually to see. So lots of modules available right now, prices dropped. So yeah, have a look at it. Let's have a quick look. Also, if we go into a product, let's have a look at Solar MD, for instance. 14.3 batteries are available now again. We worked through our backlog the whole year now, like more than 12 months backlog, and trying to catch up. I think now we're busy catching up. And if you click onto the product, you can also see again the availability graph here, and you can see what is going to be in stock. So you can see even that there is this week products which are coming in, should be able to ship out again. So there is availability right now. So use your voucher and yeah, purchase batteries. Also, one thing I want to say, forgot to say earlier, the voucher for Solar MD batteries is only valid until end of July. So use it then within July. Also, here you can see download section. If you want to get some data sheets or anything like that, certificates or whatever of products, you can find it here. On the right side, you see our prices from 1 piece to 10 pieces. So if you put in 10, your price changes, and you have got, oh, I see there's actually a mistake here. You have got a cheaper, or like it's a volume kind of like discounts for multiple products. One product I also quickly want to highlight here is our e-mobility. Also new products we have got in here is EV chargers. It's coming more and more in South Africa. So we have the GoodWe wall boxes, which work nicely with the GoodWe ES 5000 or 6000, a very nice system. Then the wall box as well as Victron wall box or EV charger also available now with in stock. Cool. Then let's have a quick look at the top here. My designs. I told you earlier that we did a PV manager design. The other day we did a training, and I made actually Kyle's house. We did a design for Kyle's house, and then once the design was done, I send it to the online store. So then it comes in here at my PV designs. And the only thing I do now is I press add to cart. Now it adds that's what we planned. Adds it all to the cart. Right, so we used IBC modules, a GoodWe 6000, the ES, the new one, Solar MD battery, of course, right, and then tile mounting systems. Everything is available right now. Actually, everything is green or orange. Orange means still enough, so we can actually very easy from here then press continue, and now with the voucher code, I even get a little discount, and order all the products right away in the online stop and get it sent to your warehouse. So very easy and quick. If you're not sure about it, but you need some people asking for quotes, I need a written quote, something written down somewhere. So what you also can do is you can press request quote and then send it to your email address if you want to, and you can send this whole quote to your email address, and you have it by email confirmed from us as well as a quote. So it makes it also very easy for you. Other than that, you can also, if you scroll down, you can also save this as a shopping cart. If you save this as a shopping cart, you can go to, oh, it changed now actually. You can go to my documents. And then on the bottom of my documents, you got your shopping carts. And then you can see all your latest shopping carts when you created them. So also very easy. And then you can load them again into the shop, into your shopping cart, a shopping basket. Also here, within my documents, same thing again. You actually have your overview of all your addresses, your shipping addresses. The same overview we saw earlier with my credit, payment terms, and all of that, as well as all the orders. So here I easily can quickly jump into an order and have a look. What did I order? What is my delivery date for this order? So yeah, this will all be then also managed from our side. The shipping dates will be updated, so you can always see under, oops, we go down here, you can see the delivery dates under my documents. So you see the actual delivery dates of these invoices or of these orders, and can keep an overview here. Cool, that's it. It was much longer than I thought, actually. This was like nearly 20 minutes now. Okay, cool. It was a lot to tell, I think. I think it's very useful. So yeah, if you're not logged in yet or don't have an account yet, make sure you get a IBC online store login and IBC portal. Okay, cool. That should be enough now. Let's hand over to Kyle. I think I'm not sure if everyone knows Kyle. Kyle was actually previously working within Solar MD and joined IBC Solar from 1st of June. So he's a new addition to our team. He has been, so his task is to work with commercial storages. So he's going to be our commercial storage specialist. So exactly perfect for today's topic. And if you have got any questions, if you do some designs for commercial battery backup systems, let us know. Speak to Kyle, and he can help you. He can assist you. That's definitely something we're going to specialize as IBC a little bit more in the next years. So that's a good start of it. All right, Kyle, I'll just going to hand over to you now. Let's stop sharing.
Cool, thanks, Alex. Good morning to everyone. Nice to see that the participation is high. It's good. Hopefully everyone can walk out of this with a little bit more knowledge or a bit more understanding. Obviously can't go too in depth given the time, but yeah, let's see where we get. Quickly share my screen. Give me 2 secs. Cool. Can everyone see the screen? Right, and the laser pointer. Happiness. All right, cool. Just a reminder again, obviously there's a 830 Rand voucher for everyone attending today, and you guys are going to get that voucher code at the end of the slide. So stick with me and it will be worth it. Right, so that's on the 8.3 kilowatt hour and the 14.3 kilowatt hour solar MDs. So I'm just going to go through a quick product overview just with regards to what's available from Solar MD, and then we'll get a little bit more in depth on the high voltage side. So for those of you that don't know, the 14.3 kilowatt hour wall mount, this is a wall mount as well as a floor mount battery, can be parallel to your desired capacity. It's a low voltage 51.2 volt nominal voltage battery, and it is rated at 14.3 kilowatt hours. This is all the specs on the battery itself. So I'll cover it a bit later on, but all of the data sheets for the relevant batteries are on the portal on the IBC shop. So if you just click on the product and you go to the bottom of the page, you'll see the data sheets there. But this is the top seller for Solar MD in terms of the low voltage range. It's extremely energy dense given its dimensions. As you can see, it's really quite compact. One of the things to note for it is it has a 6,000 cycle or 12-year energy throughput warranty, and that's then 60% capacity left after 12 years or 6,000 cycles, which is really quite impressive. And then the next one that we can quickly touch on for you is the new one, which has just come out, which is the 8.3 kilowatt hour. Those of you that are a bit more familiar with the older 3.7 kilowatt hour Solar MD, you'll see the form factor for this battery is very close to what that battery was. So sizing wise, it's really quite compact. This comes in at 8.3 kilowatt hours, and it's rated at 7.5 kilowatts. So this battery has 150 amp fuses. So it perfectly pairs with your 5-6 kilowatts inverters. Weight-wise, just 70 kilograms, so it's quite light. And the cycle life on this battery is 4,000 cycles, and the warranty is also 10 years energy throughput warranty. The cell manufacturer is a different cell manufacturer to the 14.3s. The 14.3s use CATL cells, and the 8.3 uses CalB cells. So this is the same manufacturer that the cells were produced for the 7.4 kilowatt hours as well as the 3.7 kilowatt hours. So proven brand, proven cell, and yeah, excited to see this little product come into the market as well. And then just on the 14.3s again, there is the rack mount, which is exactly the same cell composition as the 14.3 wall mount. It's just a rack mount battery, so there is a dedicated rack that can also be purchased separately, which comes with integrated buzz bars. So paralleling the batteries together in the rack, and then you just take your cabling from there, from that buzz bar through to your inverter or to your external DC combiner. Same specifications as that 14.3 wall mount. It's also 14.3 kilowatt hours, and it's a 10 kilowatt battery, which has 200 amp fuses, also in 51.2 volts nominal voltage, weight 115 kilos, and yeah, you can see the dimensions. So form factor wise, it is pretty compact for the amount of energy that you're getting out, and the same warranty. It's also a 12-year, 6,000 cycle energy throughput warranty. All right. So that's on the low voltage side. Just a quick overview. Those are the 3 batteries that are currently being produced by SolarMD. We'll step into the high voltage range of batteries, which we'll dive a bit deeper into what exactly they are, what's the working ranges of these batteries, what the individual components comprise of and what they do. And then also in terms of monitoring and control, we'll get to that a bit later. All right, so yeah, we have just an overview picture of one of the models. So this is the SS7021. It's a 15 module battery. And as you'll see now, these modules are actually the same 14.3 kilowatt hour modules that I just showed you in the rack mount, with a few tweaks to make them HV compatible. All right, so just a basic structure. Dwayne, yes, that's correct. I'll touch on that as well. I'll get to that as well. Just the basic structure of the energy storage system. For the HV batteries, the cells are CATL cells. It's a 280 amp hour cell, nominal voltage of 3.2 volts. So there's 8 cells that get put into a cell module, and 2 cell modules with a single BMS will form a battery module. As you can see, there's the 2 cell modules over there, and you have the BMS. And then to include a BMU, which is the battery management unit. This is where all your protection lies. This is where the logic of the battery lies. And pairing these 2 together, you're going to get yourself a SolarMD HV battery solution, which will look something very similar to this. They can then be connected in parallel, so that will give you desired storage capacity. Just one thing to note with your HV solutions, the voltage obviously needs to be the same in order to connect in parallel. And then you've got the SolarMD monitoring platform, which we'll touch on a bit later. And then you can see here we have a solutions picture, which is taken from one of the HV sites here in Cape Town. All right, just a reminder again, you'll see a couple of these. Just to remind you about that voucher, and the code will be at the end of the presentation. Yeah, Dylan, so the BMU is only for the HV range. The low voltage SolarMDs, the BMS manages the battery itself. In the HV range, the BMU manages the battery. All right. Okay. So just a quick overview of what we're actually looking at here. As I mentioned, the BMU, which is the battery management unit, that's where your control sits for the battery. The communication sits here. You've got mechanical isolation, and then the connection points from the battery, as well as the output connectors that go to your inverter or DC bus. Then the battery positive and negative connectors over here on the right side. So that's connecting all of the batteries in the battery modules in series to the BMU. Then number 3 is a battery module, which we've just covered. And then the HV battery module cables. That is your interconnecting cables. So the solution is provided with color-coded cables to make it easy to connect. You'll have one positive to positive connection, which comes from the BMU to your first module, and then negative to positive connectors to connect all of the modules in series. You have a longer cable to go from the bottom left to the bottom right module, which is also negative to positive, and then at the top you have your negative to negative connector, which is also a longer cable. So that is supplied with the battery itself. Your HV output connectors, so this is essentially where your energy will come from. And then number 6 is the battery frame. So the solution will also come with a battery frame like this. Depending on the size of the battery, it will also depend on what the length of the frame is. And yeah, that's also per order. All right, so just a closer view on what the BMU looks like and the functionality. So number 1 is your mechanical isolator. So this is a mechanical disconnect, which will break the positive circuit. Then we have service ports. So this is essentially just for service related and R&D things. Then I'll cover all of these together. So the battery comes with internal CAN bus communication, which will be your CAN bus 1. CAN bus 2 is inter-battery communication. So this is between BMU and BMU. And then CAN bus 3 and RS485 is reserved for communication to your external inverter. So the control, for those of you that have used SolarMD products for a long time, you'll know that the control used to be handled by the logger. And then last year, SolarMD developed the communication from the BMS, which can now communicate directly to the inverter. The BMU has the same logic, so this is for all supported inverters, either CAN bus or RS485. And then your HV output connectors. So this is where your energy will be coming from. The connectors themselves are supplied with the battery, but the cables that go from the battery to your DC bus or to your inverter are not supplied. And then you have the multi-function push button. So this push button serves a similar function to that on the low voltage battery. You've also got indication LEDs over here and over here, which will be the same as your BMS LEDs. So there is functionality behind this button as well. And this is also where you'll turn the communication of the BMU on. And then you've got your battery input connectors over here. So these are your HV input connectors from your battery modules. And then number 10 is just the power supply fuses for the communication boards. All right. It's the top view of what the BMU looks like inside. You've got your positive and negative connectors over here. So you've got your positive and negative fuses. They're both sitting on top of each other here. So this is where your protection is. So if you have an overcurrent event and the fuse blows, this is going to be the fuse that will blow. It is easily accessible, just taking off the top lid of the BMU to get to the fuse. And that'll obviously be changed when the battery is off. Then you've got the main relay over here. So this relay is your software disconnect from the battery. If all conditions are met and it's in a happy state, the relay will be in the closed state and power will be allowed to flow. But if there is an event where it's overcharged, under discharged, this relay will disconnect the circuit and the output from the battery will stop. Okay, cool. Then there is also a pre-charge circuit relay over here. The shunt, this is for measuring the current. So the current flow will be measured based on the voltage drop between point A and point B. And that's how that will be calculated. The communications PCB, so this is where your CAN bus and your RS485 communication will happen, as well as Ethernet communication. And then your HV output connectors sit over here. Your main PCB, this is your power PCB, which will essentially handle the DC to DC conversion for the power supply the control boards over here. It also supplies the relay and the sensors, for instance, on the mechanical isolator as well. And then number 10 is your mechanical isolator. And then here at the back, you just have a heat sink for dissipating any heat. All right, so just a blown up view of what each battery module looks like. The module comes with a top cover, which is a metal top cover, and then each battery pack over here has a plastic cover just to cover off those connectors. The cell covers, that, as I mentioned, yeah, that's your cell covers. Then the front of each battery module has a Perspex faceplate. This is obviously for a safety, from a safety perspective. And then also from an aesthetic perspective, it's Perspex so that you can see all the pretty lights inside. It really does look quite impressive when you string a whole bunch of these batteries together, specifically in a container solution. It looks like Christmas has come early. And then each module is also fused. So there is a 250 amp fuse on the positive side. This we would generally refer to as an idiot fuse, because if you were to connect the positive and negative together on the module, it would cause a dead short and blow this fuse. But there is also protection here in the event of some sort of overcurrent occurrence happening on the module. And then each module has its HV connectors, and this is then for connecting the battery modules together in series, and then the bottom module cover as well. Okay, and then just a front view. Yes, that's correct. And then each battery bank requires its own BMU. So you'll have one BMU per battery, and that battery will comprise of anything from 8 modules, 14.3 kilowatt hour modules, up to 17 modules. All right. Just again, here's your fuse. Number 2 over here, you've got the CAN bus communication connection point for the module. So this is just to make the ease of connection easier for you. Because the solution is modular, the adding and removing of battery modules does mean that you'll need to have some hands-on regarding the connection and the commissioning of the battery. So the internal communication over here is connected to the frame connectors here. So your top connector will go to your first BMS port CAN bus 1 over here. And then the bottom frame connector here will go to the CAN bus 2 port 2. Not to be confused with the application from the low voltage BMS. The BMS is exactly the same, but the software on how these ports are handled is slightly different in high voltage mode. All right, so then number 3, this is the BMS. So the low voltage batteries all have a BMS as well as the high voltage battery, and I'll get into what the BMS actually does on these batteries. And then again, just your HV positive and negative connectors over here. Cool. Just another reminder about that voucher for later. Right, so let's just chat quickly about the specs on the SS70XX range. So the batteries range from 7011, which is the smallest high voltage battery, and they go up to the 7024, which is the largest. And as I mentioned earlier, these can be connected, not these two, but the individual batteries can be connected in parallel with each other to increase the storage capacity. Now, the battery module that is used, that is the SS6143, and that is the same as the SS214 in its specification and sizing. It's just the application as well as the faceplate on the battery is different because it is an HV module. All right, so the SS7011, being the smallest HV battery that SolarMD has, it uses CATL technology. It's rated at 114 kilowatt hours. The power rating is 80 kilowatts. So each battery module gives you 14.3 kilowatt hours of energy and gives you 10 kilowatt of power. So you can do the calculation based on the number of battery modules that you require. And each battery module is 51.2 volts. So connecting 8 of those in series will give you 409.6 volts nominal voltage. The weight per module stays the same, it's 115 kilograms, and then the total of your 8 modules plus the frame plus the BMU will come in at 985 kilograms. These battery solutions are fully modular, so they are shipped in 115 kilogram battery packs based on the order. The frame is also flat packed and the BMU is boxed separately, so it is assembled on site. It makes it easy for installation as well as for maintenance. You don't need any special equipment. It can be done quite easily with just 2 people. And then the operating voltage. This is the operating voltage range of the battery from 358 volts up to 444 volts. And then the supported communication for the battery is CAN bus, RS485, as well as Ethernet. And then here is your dimensions. I'll just note quickly the only difference between the smallest HV battery and the biggest HV battery is actually the height. The width remains exactly the same. And then once again, because it's the same cell technology that's used in the 14.3 kilowatt hour wall mount as well as the rack mount, it's a 6,000 cycle, 12-year warranty on the battery. And then operational temperature is 0 to 50 degrees. So if we move over to the biggest solution, we go from 114 kilowatt hours up to 243 kilowatt hours. And then because we've gone from 8 modules to 17, our power increases from 80 kilowatt up to 170. And then the usable battery capacity, which is at 90% DoD, is 221. And the voltage has now also increased because we've gone from 8 modules in series up to 17. So we've gone from 409 volts up to 870 volts nominal. Weight per module stays the same, but because we've got more modules now, the weight of the total battery increases. It is just important to note the operational voltages of the battery, that you fall within the voltage range of the inverter that you're using, both on the low end and the high end. It is really, really important. If you are over that, you either will not operate or it will be at a decreased power rating that will throttle the inverter. So if you're unsure, you can come back to the data sheet or you can reach out to us and we can just clarify that for you. And then the same communication protocol, and then just the dimensions. You'll see again, like I said, the width and depth of the battery stays the same. It's just the height that changes, and the cell life expectancy is exactly the same. Okay, just to quickly run over what I mentioned now, the SS6143 battery module allows for expansion on an existing system. So if you were to start with an SS7011 and wanted to increase the capacity without buying another battery, you can add more modules, but obviously adding more modules will increase the voltage. So again, just check that you're within the voltage range of the inverter, sorry. And here's the specifications of that module, which is the same as the SS214. It's 14.3 kilowatt hours, 10 kilowatt rated power, 51.2 volts, and that's it in a nutshell. Okay, cool. So we can just quickly get into what exactly we are looking at from a more technical spec on the BMS, the BMU, just to run through what the BMS does. So each battery module has a BMS, and this is primarily used to communicate its individual battery module information to the BMU. And it also performs internal functions. So it's cell voltage measurement, cell equalization. This is what you requested earlier. It was Dwayne that asked. Each battery module has the BMS, which performs passive balancing on that specific module. Yeah. Kickstart the battery to get me. Okay, so Alton, just to answer your question quickly, the usable capacity on the battery is the usable capacity. If you go below that, there is cell voltage monitoring to open the relay contact when it reaches the low point. When it reaches that low point, that relay opens, so DC disconnects the battery, and then the battery will wait for 1 hour before it closes the relay again. It will look for charge. If it does not charge above the threshold of where it needs to disconnect, it will disconnect again for another 1 hour. It will continue to do this until it's out of that critical state. Unless it does not charge, then it will go into a deep sleep state. And then the SolarMD support will have to assist in getting the battery out of that deep sleep state. All right. All right. And then the HV management, collection and storage of data, and then the charging, discharge management of that module, and thermal management, as well as communication internally to the BMU. So the BMS measures the individual cells. Winston, I covered that earlier. It's 114 kilowatt hours at 80 kilowatt. It measures each individual cell, as well as the temperature in real time. So each cell pack has a temperature sensor, and then the BMS also has a temperature sensor on it. So there's 3 temperature sensors on each battery module. And then it is used to calculate the individual battery voltages. The BMS has resistors on the left side of the BMS, which will passively balance the cells when it is in the balancing range. So the batteries are set for top balancing, so they will balance when the battery is full, and it will balance when the current is low. So it will generally be in the floating stage of the operation. That's when it will balance, if the cells are above the delta, which is required to balance. And then because it's recording the cell voltage and module temperature, it needs to relay the critical information to the BMU so that the BMU can then calculate the charge and discharge protection. Cool, thanks, Leo, thanks for that. And then the intermodular CAN bus communication. So each module is connected then together on a CAN bus line, which connects to the BMU, and all the battery modules will report their individual information to the BMU. The BMU uses that information to make operational decisions. Okay, so the information that gets stored to the BMU can then also be seen through the Logger V2, which is the SolarMD monitoring device, and then that can be viewed on the MyPower24 platform. This will then be the charge and discharge capacity of the battery. The minimum and maximum temperature of the cells also gets recorded and can be viewed in live time. The module temperature itself, and then as well as the voltage maximum and minimum for each cell in the battery, as well as per module. And just to run through what the BMU does, or just a note on the BMS. So the BMS on the high voltage side, it will handle the same operation on the low voltage side. The only thing is it doesn't communicate CAN bus info to a BMU. The batteries communicate with each other. So the cluster is not formed to the BMU. The cluster is formed internally on the BMSs for the low voltage application. I'll explain what the cluster is shortly. Then the BMU, like I mentioned, is responsible for collecting all the information from all the modules. And then if you have multiple BMUs in your system, the BMU share that information with each other. So this is then responsible for collecting all of that information, calculating the state of charge, exchanging this information within that internal CAN bus on the BMU so that they can make a decision on charge and discharge parameters based on the whole battery bank and whether or not it is safe to operate. And then the BMU also does external communication with inverters or chargers or the logger V2. As I mentioned in the beginning, with the different communication ports on the BMUs, the CAN bus 1 is reserved for internal communication for that battery to its battery modules. The CAN bus 2 is used to communicate between BMU to BMU so that they can share their relevant battery information with each other. And then CAN bus 3 and RS485 or Ethernet is used to communicate this information to external devices. And then the information management and reporting will be done to the logger V2 via Ethernet. And each BMU is responsible for controlling the main output relay of each battery. So if the battery is in safe operating conditions, the relay will be closed, which means that you can charge and discharge the battery. If not, the relay will open and wait for the conditions to be met again before closing the relay. And then the BMU monitors each of those battery modules. So the battery's voltage, the current, as well as the temperature limits are taken into account. And it will disconnect the battery from the DC bus under abnormal circumstances. As we went through just an overview of what's internally in the BMU, that's your positive, negative fuses, mechanical isolator, protection relay, pre-charge relay, current sensors, temperature sensors, low voltage power supply board, and communication boards. No, Dylan, the logger V2 it's a piece of hardware. It's a hardware device which is manufactured by Solar MD. It's also on the online shop. It connects to the MyPower24 platform, which is Solar MD's monitoring platform as well. So the logger V2 is if you take a Servo GX, the logger V2 is essentially the same thing for Solar MD. Your charge and discharge management. All right. This is handled by the BMU internally based on the charge and discharge logic that is set on the BMU. So this is predefined by SolarMD based on the tests that R&D have conducted. For the most part, it is exactly the same logic that is applied to the low voltage batteries because the cell technology is exactly the same. Just the numbers are a little bit bigger. So this will be your maximum allowable charge and discharge current for normal operation. And this is based on the voltage, current, temperature, state of charge, and state of health levels of the battery. So there's a lot of factors that need to be taken into account for optimal operation. Any of these not being within optimum range will then cause either a throttled operational step to be given to the inverter, or it will cause a disconnect from the battery from the DC bus. And this information is then sent through to the inverter's chargers and also reported to the logger itself, either again via CAN bus, RS485, or Ethernet. Then the limiting information. So this is very important when it comes to a charge and discharge cycle. So sending limiting charge information to the inverter when the battery is full, to essentially throttle the charging, to stop it from charging the battery so that it doesn't overcharge. And this is the same from a discharge condition, to not under discharge the battery. So SolarMD works really closely with the various inverter brands to build those protocols for the inverters into the logic of the BMU, which allows this information to be conveyed to the inverter so that it will limit the charge and limit the discharge to essentially protect the battery. All right. And if these requests are not met from the inverter side, if it continues to charge and it's overcharging the battery or under discharging, the battery will disconnect itself from the DC bus, and this will be under high or low cell voltages, high or low temperatures, or a communication failure between the battery modules and the BMU. So it's just another protection step that is built into the BMU, that if it loses communication with any one of its battery modules, it will disconnect itself from the DC bus because it doesn't know what's happening with that battery module in its stack. Cool. Stick around, the voucher is coming. All right, onto the MyPower24 monitoring platform. So this is SolarMD's native monitoring platform. It is built by SolarMD itself. Okay, Patrick, so if the battery gets overcharged, it's a similar condition to what I mentioned earlier to Alton from a under discharge. If the battery is overcharged, it will disconnect itself from the DC bus, and then it will wait for 4 minutes to reconnect itself to the DC bus if it is below the threshold. If it is, it will look for discharge. If it continues to overcharge, it will again disconnect itself from the DC bus, and will continue to do this until it comes below that threshold. If it is a balancing, a cell balancing requirement, then the cells will continue to balance in this time. Dwayne, I'll get to that shortly. All right, so MyPower24, this is the web portal, so it is available on your whichever browser you want to use, so either on a PC, laptop, or on your cell phone. And then there is also a mobile app, which gives a little bit more of a client-friendly experience. The web portal itself is quite in-depth. It has a lot of information, a lot of features. So just to run you through what a basic overview of what the devices list would look like. The loggers come with dry contact relays, as well as a digital input and output and analog input. Then here you can see that this specific system has SolarMD H8 series. These are the high voltage batteries connected to the logger. And then the logger itself also has a virtual device over here with a couple of features in it. And then there's a power manager, which is responsible for handling all of the data from the various devices. And then just to give you an overview of some of the supported inverters from SolarMD side, from a monitoring perspective, as well as a control perspective. You've got the SineXL inverters. It's a fully modular inverter solution, which can be hot swappable on site. It's really quite a cool product. There's the AEG battery converters. They're also supported. Then the ATES range, the hybrid solutions from ATES, the HPS, as well as the battery inverters, the PCS, and also the DC to DC converter, their PBD is also supported. A wide range of SunGrow inverters is also supported by SolarMD. So the SunGrow battery inverters are all supported. And then the Kahuatech battery inverter is also supported. So with all of these devices from SolarMD's logger, you are also able to monitor the inverter. You can make settings changes to the inverters as well. And then with the SolarMD EMS or energy management system, you can also control these inverters based on various conditions. Should it be just to control a grid tie inverter, or whether it is a energy arbitrage system on a time schedule. You can also set up a time schedule there, or even peak shaving. So there's many energy meters that are also supported. So you can use that for your peak demand, and then use the system to shave those peaks. Terence, SMA is not currently supported, but I have heard that the SolarMD R&D is in the pipeline to support as well. Linda, does that mean a cycle is a discharge and a subsequent recharge? All right. So regarding what is classified as a cycle, a cycle is a complete 100 to 0 discharge. So if you cycle the battery at 20% per day, that means it will take you 5 days to do one cycle. Hope that makes sense. All right. Here's a sort of all-inclusive kind of system. As I mentioned earlier, you've got the relay contacts here. Here we have an SMA energy meter, which is monitoring the grid. They have an EV charger over here, which will handle their grid, because this is a fully off-grid site. So they use the EV chargers, which are also supported by SolarMD, to bring the grid in. They have 12 HV batteries, but one of them, as you can see here, has actually lost communication with the logger. So you can also get a good overview of what's happening with the system here. And then, yeah, we have the SunGrow battery inverter, and then also the SunGrow string inverters, which are also connected to the logger. So this will give you a whole holistic view over the whole system of what they have installed with all these devices that are supported. Yes, Kenyon, the data that is logged by the logger itself is first stored locally and then uploaded to the MyPower24 platform. So if the logger is not connected to the internet, it will store the information locally. And when it does get connected to the internet, it will upload that data as well. But you can view the information locally, offline. Right. So just to go back to this one here, we have the dashboard, which I'll show you now, and then you also have charts. So there's a power chart as well as an energy chart. We're viewing my devices now. There is also events, so that you can go and view if there were any events within these devices. If it was a disconnect of a specific device, maybe there was a high cell voltage incident with the battery. Yeah, whatever it might be will be stored under the events. And then, Rian, the local data is stored indefinitely until the memory card is full. But I've seen loggers with 5 years of local data that can still log local data. All right. So just to give you a quick snapshot of what the dashboard would look like for this specific site. Here you can see that the grid is being monitored by that SMA meter. So that's been reported here as 105 kilowatt coming in, and they've got 153 kilowatt being produced by the PV. There is their load, which is 253 kilowatt, and then the status of the batteries at the time was 92.2% charged, taking in 2 kilowatts of power, and the available capacity was 787 kilowatt hours. On the chart side of things, here is just 1 day view, which I took on the 26th of June, and it was from midnight until 2 p.m. This is completely scalable. You can view up to 7 days worth of data in one screen, but you can scroll back indefinitely as long as the logger has logged that information. And you can go and see that 10-minute data point, what was happening at that specific time, what the consumption of the site was, what the storage, the battery capacity was at, the voltage, what PV generation was happening. Here was the grid import. And then because this is 10-minute data point, in that time, the peak was 54 kilowatt for charge and 17 kilowatt for discharge. Right. And then, like I mentioned, the mobile platform. So this is exactly the same site, but this is just being viewed on the mobile device. So this is much more client friendly. You can't make settings changes from here. So for the installers, this is quite a nice tool to give to your clients. And then you will use the MyPower24 platform if you need to go and make any changes to the system. But the client can log in and get an overview of what's happening. It's nice. It gives you a nice little graphics on what's happening here. You've got the financial part over here, which tells you what your ROI on the system is, what your benefit to the environment is, and then you also have the overview over here. There is also down here, there's charts. You can also go and view the individual devices to see if they're online, and then your profile. And then this is what the chart will look like. So you'll see this chart is very similar to the one on the previous slide. Gives us again the load and the storage, what the grid power was, and also the PV production. So this was at 8:47 in the morning. Okay. Now we jump back to the web portal. I just want to go into a bit of in-depth information on what you can see on the battery side. So there are various roles that can be granted. For the most part, the installers and clients don't have access to settings, network production, or developer. This is reserved for SolarMD support and R&D. The information that you do have available to you will be your general information about the battery, the actual data, and the cluster data. So this is where you'll spend most of your time reviewing the batteries. And here we can get a status overview of what's happening with this specific battery. Number 2, we can see that that relay is closed, and this is the current pack voltage. It has a current, a positive current, so it is busy charging. And this is the power, which is calculated based on the voltage and current. And the capacity on that battery is 32%. So at this rate, the battery will take 21 hours to charge. So this it's just a 1-minute data point that we use to calculate how long it will charge based on the average of this current. And over here you can get a overview per battery again. So if there is a battery that is limiting the charge or the discharge, it will report that information over here under your charge and discharge control. So for those of you that are using the loggers to view the low voltage batteries, this information, all of this is exactly the same. It's just, like I mentioned, this number is smaller, but your cell data is exactly the same with the delta over here, and your charge and discharge control levels are also based off a percentage. 100% means that full values are being sent from this battery. So it's full current limit and it's full voltage limit. And when it reaches the top end from charge or the bottom end from discharge, these will start to limit and then send limiting information to the inverter to either stop the discharge or stop the charge. So we can see there's 9 battery modules in this one. So that's 9 times 51.2 volts times 14.3 kilowatt hours. The total number of cells is 144 cells. So there's 16 cells in each battery module, and there's 9 battery modules, so that's 144 cells. And then here you can see that module 3A, cell 1 is the lowest on the cell voltages, and module 1A, cell 8 is the highest. And we have a cell delta of 8 millivolts, which is actually really good. And you can see minimum and maximum temperature of your pack. And then also here, there is a tooltip. So if you hover over each of these, it will tell you which which cell it or which battery module it is that's the lowest and which one is the highest. In the protection state, the isolator is closed. So that is your mechanical isolator, and then your software disconnect relay is also closed. So we have a normal operation over here. Balancing information, you can come here to see if the battery is busy passively balancing. VB complete means that the voltage balancing is complete. Currently, we are below the point where the balancing will happen, and also the current is a bit too high to start the balancing here. And there's just some more temperature information here, the BMU's internal temp, and then the pre-charge circuit. If we move down to the individual modules, you'll see here that there's module 1A and then 1B. The naming convention actually comes from the previous generation of high voltage batteries, where each battery module had 2 BMSs because there was 32 cells, but now there's only 16 cells in each module, but the convention has remained the same. So module 1A will be the CAN bus, one line connecting from the BMU to the first battery module will become 1A. Whichever line connection from 1A to the second module will become 1B, and so forth. So you'll have 2A, 2B, 3A, 3B, and so forth. So here you can see on this specific module what the lowest and the highest cell is, what that cell delta is, and that individual pack voltage. So we bring it back down to a normal 51.2 volt pack, and then the individual module temperature, and you can go and view each and every single cell in this module, all 16 cells. You'll see what the delta is to the module based on the lowest cell, and then also the pack delta based on what the total pack, where this module falls in line with that pack. All right. And then if we go to the cluster data, so this is the information that will be reported to your external device. This is what gets reported to the inverters or to the charger, the charge limits as well as the discharge limits. And then this information can also be extracted from the logger via either Modbus TCP or over API if you wanted to use an external monitoring or external controller and you needed this information. This is the information that can be sent. So the cluster here, we can see that there is 4 batteries in total on the logger, and the cluster also confirms that there is 4 batteries in the cluster. Currently, there is 4 batteries online. As you can see, there's 4 batteries online, and there is DC connected batteries is 4. So none of them have any specific reason to be disconnected. They're all operating normally. And then each battery will have a role in the cluster. There is always one master in the cluster, and this is the battery that will report the information to the control device, so to your inverter or to your charger. The cluster master is not determined by which cable is connected to the inverter. The cluster master is determined by the serial number of the BMU, and the one with the lowest serial number will always be the master. And then each of these batteries will be the slave. So all they do is they report their information to the master, and that has to do with their charge and discharge limits. And then the master will use that information and make the operational call whether to either throttle charge or throttle discharge. In this cluster data, this is typically what gets sent through to the inverter itself. So if you go and view on the inverter, if you have active communication from your battery, you will see then what the average state of charge is. So there's a combination of all 4 batteries together. And then what the rated charge and discharge current will be. This is based on the number of online batteries. And the online is also being connected on CAN bus 2 together so that they can relay that information between each other. And here's the limits that are sent to the inverter. So currently it is 100% charge control, which means we are in full swing for charging. and it's 800 amps limit because each battery is rated at 200 amps. The discharge is exactly the same because we're in normal operation. So we also have a discharge limit of 800 amps. And then the charging voltage, this will change based on the number of modules you have connected in series. So the bigger the HV battery, the higher this voltage limit will be. The current will always be 200 amps per battery. And then the same goes for the discharge voltage. This is the current discharge voltage limit, and this will also increase based on the size of the battery. And then collectively over these 4 batteries, over the 144 cells per battery, this information is now reported here, and this is your lowest cell across all 4 batteries, and this is the highest cell. Again, there's a tooltip, so if you hover over min cell and max cell, it will tell you which battery based on serial number, as well as which module and which cell it is. And at this point in time, the cell difference is 45 millivolts. And here you have lowest and highest temperature based on all 4 batteries. This is the usable capacity. So this will be related to the state of charge as well. And this is the total capacity of all of these batteries put together. So it's 280 amp hours across each battery multiplied by 4 will give you your total rated capacity. And because all of the batteries are online, our online rated capacity is 1120. If we had an offline battery, it would show here what that rated capacity is. And then from the external communication, this specific inverter that's connected to these 4 batteries was an ATES HPS solution. So the ATES uses CAN bus. The information then that is being relayed to the inverter is coming through CAN bus, which is on CAN bus 3. And this master battery over here is relaying the information. You can see there is RX frames for receipt and then TX for transfer. These are the frames that have been sent through to the inverter. You can see the bit rate as well as whether the line is connected or not. So this is also a helpful tool in a bigger bank to determine whether or not you have maybe a faulty cable or it is a termination issue on the end of the CAN bus line. And the same with the RS485, because it's not being used here, the line state is disconnected, and there's also no traffic here. All right. Last reminder, we are almost there, so just stick around a little bit longer. With regards to piecing the solutions together, you know, in the information age, we're kind of overwhelmed with the amount of data that we have to try and remember and absorb. I find myself having to refer back to data sheets all the time. And a great resource for that, as Alex has already mentioned, the online shop. If you guys aren't signed up, please get yourself signed up. The data sheets for each product that we sell is also listed on the site. So if we're going to specifically a SolarMD HV battery, I've got the 7011 over here. So I'll go to storage and to SolarMD. I'll go and click on my battery here. You'll see all the other batteries that are also listed, as well as the capacity. And it tells you over here what the number of modules is that's inside the battery. We go down. You'll see at the bottom of the page, you've got your downloads, and here's your data sheet. So you download the data sheet and then go and view the data sheets of your inverters, go and view the data sheets of the battery, make sure that you're sizing your system correctly based on the operational parameters of the inverter, that you're not under-speccing or over-speccing the battery. And if you're unsure, get in touch with us. We can advise as well what is the best solution based on the installation requirements. Okay, cool. And then just to touch again on the technical services which Alex mentioned earlier, on your portal, if you go down to technical services, we've got the commissioning assistance over here. We can do single line diagrams for you, can help you size that system correctly. this month, July, we've got that PV Manager special where we'll do free designs for you as well. So lean on us to help you size the system, especially in the beginning stages, you know, when we're all still learning. It's a great tool to have people in your corner that can guide you and assist you in the right way, and piece together the solution that's best fitting for the need of a client. All right, cool. And then, yeah, like I mentioned, we've got that free PV Manager design for the grid type project. So yeah, get in touch with us so that we can assist you with